There you go. All right, this is lesson 1-4 for Algebra 1, and today we're going to be talking about properties of real numbers. First thing we're going to talk about is equivalent expressions, which are when you have two expressions that have the same values for all variables. And how would we be able to show that two expressions were equivalent? What's equivalent kind of sound like? Equal, right? So we use these a lot, and you might not even know it, but equivalent expressions are when you have two math sentences. You might have something like this, 4x minus 5. Oh, something like that, right? Is there an equal sign there? Yes. Is there two expressions, right? One on the left side, one on the right side? So these are equivalent expressions. Most times I'm just going to talk about them, and I'll probably say, equation, because I think that's what kind of what we're used to. But in the book, if they talk about equivalent expressions, it should look like this. All right, now these properties are on page 23. Okay, and these are a lot of properties that we already know and everything. Now, I would probably not write them down right now. Right? You can go back and just write, page 23, so you can go back. You might want to write them down for a test because you can use notes on a test or a quiz, right? And they might ask you what the, addition property is or something like that. So let's look at what these say. Right here we have addition property, and it says A plus B is equal to B plus A. Did you guys know that? All right, and if we look right here, 18 plus 54 gives you the same answer as 54 plus 18, right? And the simple one that I like to use all the time is 2 plus 3 is the same as 3 plus 2. Right? That's just called the commutative property. We're talking about the addition commutative property. Right. Multiplication, same thing, right? A times B is equal to B times A. And we know that by something like this, or 2 times 3 is 6, 3 times 2 is 6. And so that one's, this top part's commutative. This bottom part's associative. And if we look at those down here, what we do is we're switching the parentheses, right? They start off at the beginning of the problem, they go to the end, right? And what the associative property basically means is the order in which you add or the order in which you multiply does not matter. Right? It doesn't matter if you multiply one pair first or the last pair first. Right? Order doesn't matter. And it's got a couple examples over here. This is, again, found on page 23. If you're like me and have trouble keeping the difference between associative and commutative, right? I mean, I could use both of them, but I couldn't tell you what their names were, right? But is that something I might ask on like a test or quiz, right? Is this an associative property? And you have to say yes or no, right? You might want to put these down in your book or in your notes, and they're from page 23. Right? So that'd be something that you might want to do in the future. Right. We also have some more properties coming up. First one's called identity property. Okay, identity. What identity means in math is that you're not changing something. Okay, it gets to keep its identity. Okay, and in addition, what do we do to addition to keep something the same? If we're going to add something to it, what do we add? Yeah, you add 0. If you add 0, it doesn't change, right? And you'll see that here with A plus 0 is equal to A, and 12 plus 0 is equal to 12, right? It's the identity. It doesn't change it. We're not going to put a mask on 12 to make it a 13. No, we're going to leave 12 the same. Right? And what about the same thing for multiplication? What number do you multiply by to get the same number? 1, right? So it's a little bit different because this one has 0, but this one has A times 1 is A, and 67 times 1 is 67. And so that's identity. The next one on the list is the 0 property. And we're talking about multiplication here. Right? Now, 0 property, what do you think our answer is supposed to be? 0. And what do we multiply by to get 0? 0, right? It doesn't matter how big or small A is. If we multiply by 0, we're going to get 0. Right? Now, are there anything that I've gone over yet that you guys didn't already see before or know before? All I'm doing is putting names with them, right? All right. Right, and the last one is multiplication property of -1. Right, what happens when you multiply by -1? Negative, but what happens to the number? Yeah, you times it by negative, it does, right? But all that happens is the sign changes, right? The number, like 9, didn't change. It just went from a +9 to a -9, right? So we're not changing the number, we're just changing the sign in front of it, right? Good, and that's the multiplication property of -1, right? Okay. So, looking at these ones, let's tell about which property is used. So if we look at A, which is 42 times 0 is equal to 0, which one's that going to be? 0 property of multiplication. All right, that's good. Zero property of multiplication. Part B, look at part B. Thank you. All right. What's this one going to be? Do we know? Well, I know it's either between commutative or associative, right? But which one is it going to be? Associative, right? And we can check that table on, what was it, page 24 or 26 or something? 23? Yeah, we can check the table on 23 and make sure you get these in your notebook so when you're taking a test, you don't have to sit there and think, well, I know it's one of them, but I need to guess. All right? But we said this was associative, right? All right. Associative property of what? Of what? Addition, right? Because it's talking about addition, so. Property of addition. Good. All right. What about part C? Identity, because of, look at, we had 10x. Did 10x change from here to here? No, it didn't. It stayed the same, right? We didn't change it, so it's the identity. Identity property of addition. Okay, good. All right. Until you get used to the properties, a lot of times you'll just be matching them, right? Looking back at the table, figuring out which one it is. But as soon as you get a hang of it, you know, it's pretty easy. You just figure out which one it is, and you say property of, and then whatever operation you're using, either addition or multiplication. All right, now, this one we're going to be using a little bit of mental calculations, all right? But we have a go to the movies. The movies cost $7.75. A drink costs, what was a drink? $2.40. And popcorn costs $1.25. Right? And you want to know what's the total cost of ticket, drink, and popcorn, right? Using mental math, right? Because you don't bring calculators to the movie theater. Now I know you have a calculator on your cell phone, right? But you don't bring a cell phone in there because you don't want to talk on the phone and make everybody mad at the movie, right? So you don't have a calculator. So how are we going to do this? So, I mean, without a pen and paper, you try to add, right? So we're going to say this is $7.75 plus $2.40 plus $1.25, right? And then you start thinking, well, $7.75 plus $2.40, that's 9, and then you add the change, and you have to carry a 1, which makes a 10, and then we have to put some other. It's kind of tough, isn't it? Oh, 125, yeah. I don't know. There we go. That looks better, right? Okay, so adding 775 and 240 is kind of tough, right? But what do we know about addition? Does it matter which order you do it in? No. So would it be easier if I wrote it this way? And I already heard somebody get the answer, so. All right, would it be easier? What's 775 plus 125? 9, right? So this together is 9. What's 9 plus 240? 1140. There we go. That's a lot easier to add than the other way, right? Yeah. So 1140 is the answer. So remember that addition order doesn't matter. So if it's easier to add one pair first, then do that, and then add the second part after. Now, on these ones, we're going to simplify each expression, okay? Simplify each one. So let's start with A. Right? And what's the operation happening on A? Yeah, timesing, right? We're going to multiply them all. Does it matter which order you multiply in? No, so could I multiply the numbers together? Yeah, what's 5 times 3? 15. And. Okay. What property says order doesn't matter? Associative. All right, B, part B over here, we have addition, 4 plus 7B plus 8. Now, we talked about orders of operations, and we said that we needed to do the parentheses first, right? Is there anything we can do inside those parentheses? No, there's nothing that we can do, nothing more that we can do to that. But we also know what about addition? Does it matter which order you add it in? No, so could I change the order? Yeah, so let's say 4 plus 8 plus 7b. 4 plus 8 is so is that simplified? Yeah, it's less numbers than before, so it's simplified. And on the bottom here, part C, to simplify this one, does anybody have any ideas what we're going to do? Yeah, a lot of people are going to say, hey, I know that division they'll cross off reducing to 6x, right? Okay, good. Now, I'm going to redo this problem to just show you how we use the properties to come up with that. Okay. So we say that multiplication doesn't matter. So I'm going to take 6x times y over y. Right, is everybody okay with that? Doesn't matter which order you multiply in, so I'm just going to break them up. And we know y divided by y is 1. 6x times 1 is 6x. All right. So on this one, we actually use two different properties. What property do we use from here to here? Associative, right? Because the order doesn't matter. Which property do we use from here to here? Identity, right? Because if it didn't change the 6x from one side to the other. So we use two different properties on that one. All right. Now, the next thing we're going to talk about is deductive reasoning and counterexample. Deductive reasoning is using logic to get an answer from a certain amount of facts given to you, right? And anybody that's seen the Sherlock Holmes movie, you know, I always hear about him doing a lot of deductive reasoning from logic. A counterexample is a statement that proves another statement false. And you only need one counterexample to prove a statement false. Okay? So if I made a statement in here that said, I'm taller than everybody in this classroom, right? How would you prove me wrong? Standing up next to me and being taller, because you stand up next to me and you're shorter than me, then it is proving me right. How many people need to be taller than me in order for my statement to be false? One. Right? If one person's taller than me, then that statement's false. So only one counterexample is needed. What if I said I was faster than everybody in this classroom? You're not going to make people around? I'm pretty much certain that I'm not the fastest in here. All right, has everybody got that down? You're always the slowest rider. 5, 4, 3, 2, 1. All right. Now it's like these ones are going to be math statements, and they want to know, is this true or false? If it's false, give a counter example. So on the first one, they say for all real numbers, a times b is equal to a plus b. No? What's a counter example? We need a specific example that will prove this false. So we need numbers. 6 times 1, 6 plus 1. 6 times 1 is? 6 plus 1 is? Are those the same? So that is a counter example. Good. Part B. Oops, there we go. For all real numbers, a plus b, parentheses, plus c is equal to b plus parentheses a plus c. Right. Sometimes you'll know right away whether it's true or false. Sometimes you're going to think, well, I'm not sure, so maybe I should plug in something to see what happens, right? So, Chase, you can give me some numbers? 7 plus 6 plus what? Well, we only need 3 of them. Right? And then B was 6 plus parentheses A was 7 plus C was 8. All right. So over here, 7 plus 6 is 13 plus 8. Over here, 7 plus 8. 15 plus 6. Well, that wasn't a counter example. That was one of the ones that's true. All right. So do you guys think this is true or false? Now, what does the associative property of addition say? What does it say about the order that you add? Doesn't matter, does it? So, in this one, does order matter? No, it doesn't matter if you add the biggest one first or last or in the middle or whatever you want to do, you're always going to get the same answer. Right. Your homework's on page 26. Hit 7 through 35 odds, 36 through 55.